Welcome to the Foundry by Forge College. I'm your host, and today we are tackling the ultimate engineering challenge of our Advanced Solana Concepts track. Think of today's explainer as the final assembly and the crucial diagnostic test of your engineered prototype. Basically, your capstone research paper on Solana's Cloudbreak. You know, you've spent all these previous lessons meticulously drafting technical documentation, extracting data, and writing scripts. Well, now it's time to bolt it all together.
Right off the bat, let's lock in on these three words: traceability, clarity, transparency. These are the absolute core goals of our build today. Because we aren't just trying to pass a simple writing test here, we're making sure your technical paper isn't just a flat, lifeless document. It needs to be a verifiable, reproducible machine. When a reviewer reads your capstone, they shouldn't just have to take your word for it. Let's be real, reviewers have major trust issues anyway. They need to be able to actually prove that you're right.
So here is our blueprint for today. We'll be hitting 1. The final assembly, 2. Manuscript mechanics, 3. The reproducibility engine, 4. Running diagnostics, 5. Packaging for launch, and finally, the next horizon.
Okay, let's jump right into part 1, the final assembly. First things first, we need to organize that workspace. Imagine you're standing at a literal workbench, and it's just scattered with all the raw data and scripts we built previously. It's a mess, right? We need to bring order to that chaos by building a versioned root directory. Let's call it something like Cloudbreak Paper v1. Inside that, we map out these exact 5 folders: manuscript, figures, data, scripts, and appendices. What we are doing here is setting up a clean, highly orderly assembly line for our components. By putting every single piece of data and every script into its proper bin, we guarantee that when the machine is finally turned on, those gears are not going to jam.
Moving on to part 2, the manuscript mechanics. Think of this as your user manual. See, your manuscript itself isn't just some standard essay. It acts as a highly detailed user manual for anyone looking under the hood. These sections, they function like interlocking gears. Your abstract and introduction set the stage, sure, but notice how every subsequent section completely depends on the previous one. Your methods absolutely must enable the results you're describing, and every single claim you make in your results section, it has to point directly to a specific figure, a table, or a row in those technical appendices. It's an unbroken chain of logic. If you claim Cloudbreak processes state access at a certain blazing speed, well, your methods need to show exactly how you measure that. No magic tricks allowed. Seriously, reviewers despise magic tricks.
All right, part 3, the reproducibility engine. This is where we ensure verifiable findings.
This right here is the absolute core motor of your submission. We aren't just handing over a flat, static PDF where your amazing data is trapped behind a wall of text. No way. We are delivering a dynamic, reproducible package. You are giving the reviewer the PDF, yes, but you're also handing them a top-level script like a Makefile or a shell script along with the raw data itself. In practice, this means a reviewer can essentially press one single button and your entire Cloudbreak analysis rebuilds itself from scratch right before their eyes. How cool is that?
But to make that happen seamlessly, you're going to need a reproducibility manifest. Think of this as a highly specialized README document. This manifest is literally the wiring diagram that connects the claims in your manuscript to your actual script names and output files. It tells the reviewer the exact command sequence they need to use, exactly what outputs to expect, and any runtime considerations they should know about. You are leaving absolutely zero guesswork here. If they need to install specific dependencies first, it's all mapped out clearly right in the manifest.
Which brings us to part 4, running the diagnostics. It's time for some crucial pre-flight checks.
We really need to avoid the dreaded, well, it works on my machine syndrome. Because, let's face it, reviewers don't care if it works on your machine, it has to work on theirs. So we start safely with what's called a smoke run. And it's exactly what it sounds like. You turn the machine on briefly just to see if your computer metaphorically starts emitting smoke. It's just a quick, maybe 5 to 20 minute test using a small sample dataset. Before you commit to a massive compute cycle that might tie up your machine for hours, you execute this lightweight run just to make sure the gears actually turn, the file paths resolve, and the correct test files pop out exactly where they should be in your figures folder. Now, if the smoke test passes and nothing catches fire, awesome. You move on to the full diagnostic checklist. First, you run the full reproduction script. You monitor closely for deterministic outcomes, meaning we want 0 random, unexplainable surprises popping up. Then, you verify that these newly generated outputs perfectly, and I mean perfectly, match the figures in your PDF manuscript. After that, you audit your own documentation. Pretend you're a blind reviewer who has never laid eyes on this project before. Does it all make sense? Finally, you log every single outcome, whether it's a pass or a fail, tightly into a file called verification_log.md.
Okay, Section 5, Packaging for Launch. Here is your absolute minimal checklist. Your diagnostics are green, so let's pack this up. You've got your final manuscript PDF sitting neatly in the manuscript folder. You've got your top-level script ready to go, your analysis scripts, those gorgeous generated figures and tables, and of course, all your data manifests and appendices are in their perfectly designated spots. Your job now is to bundle all of these precisely placed components into a single, consistently named compressed archive. You're making a zip file where every single citation, every folder name, and every file path is absolutely flawless.
Finally, Part 6, the next horizon. Let's look at what's beyond the capstone.
So, you finally click Submit on that zipped archive. Go ahead and take a breath. Your Cloudbreak state storage capstone is officially complete. Feels good, right? But in the world of Web3 engineering, the journey never really stops, does it? So I have to ask you the big question. Are we ready for FireDancer? Make sure you hang on to your reproducibility package and those verification logs we just made. Because truly understanding Cloudbreak's storage behavior, that is the absolute perfect launchpad for our next module, where we'll be exploring validator architecture, specifically zeroing in on FireDancer. And those rigorous analytical skills you just proved you have, they're going to be exactly what you need.
So it's time. Submit your reproducible package. Huge congratulations on completing this intense build. Make sure to visit forge.college to learn more about this subject and dive into other fascinating Web3 topics. You've just proven that you can engineer verifiable state storage. But what happens when the network suddenly demands you process 1 million transactions per second? Keep building, keep verifying, and we will tackle that seemingly impossible question in the next explainer. See you then.